what will happen? This will convert it into carbon dioxide and water, which cannot be further converted into methane and oxygen, and that is the reason they are known as irreversible reaction. Now, some reactions are reversible and both reactants and products are formed simultaneously. That means as the reaction goes, what will happen? Reactant changes into the product and product can also changes into the reactant. Then this is known as reversible reaction. For example, melting of ice or conversion of water into the ice. As the temperature increases or decreases, this will happen. So this is about the reversible and irreversible reaction. Now, what does mean dynamic equilibrium? See, always remember that dynamic equilibrium can occur into a closed system. This will never happen in the open kind of system. This will always happen in the closed system. So must have a closed system. So reactants and products can't escape or be added. That means the rate or speed of forward reaction is always equal to the rate of the reversible reaction or reverse reaction. As you can see on your screen, there is a container which is completely closed, and in this container there is an ecosystem, and this is a closed system. That is why the equilibrium stabilized in this container is known as dynamic equilibrium. This system is closed, so that is the reason the equilibrium stabilized in this condition is known as dynamic equilibrium. So this is the another example of dynamic equilibrium. You can see here there are two systems. One is open system and another one is, that is second one is closed system. We close this system with the help of a cover. So what will happen? As in the open system, what will happen? If we give some temperature to the open system, then what will happen? The liquid present in this container will be evaporate. So as it will evaporate, what will happen? The amount of liquid will decreases. In the case of second system, that is the closed system, what will happen? Condensation as well as evaporation both can be occur. That is the amount, total amount of the reactant or product cannot be further changed. That means in this case equilibrium can be stabilized, because what will happen? The forward reaction as well as backward reaction, both kind of reaction can be occur. So quantities of reactants and products do not need to be equal. That means rates of reaction, that is forward reaction or reverse, must be equal. That means rates of forward reaction is always equal to the rate of the backward reaction, as you see on your screen. So liquid water can be converted into gaseous form by evaporation, and by condensation this will further convert it into gaseous to liquid form. So this is known as dynamic equilibrium, because here we can see here there are two systems. Open system cannot be stabilized or equilibrized. So we can say that in closed system dynamic equilibrium can be stabilized. So now we are going to discuss about the phase change equilibrium. What does mean phase change equilibrium? Dynamic equilibrium is also known as phase change equilibrium, but dynamic equilibrium can be occur into the closed system equilibrium or phase change equilibrium. We don't have any kind of closed system. In open system that may be occur. That means if we talk about the phase change equilibrium at 0 degree Celsius in a closed container, solid water converted into liquid water as well as liquid water can also be converted into solid form, that is the ice form. So we can say that rate of melting is equal to the rate of freezing. That means amount of water is not equal to the amount of ice. So we can say that amount of water is not equal to the amount of ice, as you can see on your screen. Our next topic is solution equilibrium. So whenever equilibrium gets stabilized in the solution, then we can say that this is known as solution equilibrium. So what does solution means? Solution having two things. One is solute, another one is solvent. So whose concentration is more, we can say this is a solvent, and whose concentration is lower, we can say this is a solute. This does not depends on the state. That means we can say liquid can also be a solute or solid can also be a solvent. It totally depends on the concentration or amount. So in our solution, what will happen, you can see on your screen, solid sodium chloride, which is known as normal salt, can be dissociates into the water, and this will converted into sodium ion and chloride ion. Here you can see in the reaction, these two charges are in the aqueous form. Why we can say? Because aqueous means what? Aqua. Aqueous means aqua, that is water. So when we put this NaCl salt into the water, this will converted into sodium ion and chloride ion. So eventually the rate of dissociation will equal to the rate of precipitation. The solution will be in equilibrium, but the ions will continue to dissolve and precipitate. That means here you can see NaCl will convert it into sodium and chloride ion, and the backward reaction can also occur. Because of that, we can say the rate of dissociation is equal to the rate of precipitation. That is the reason in this condition equilibrium stabilize. So in this condition equilibrium stabilize means the formation of solution whenever equilibrium can be stabilized, this is known as solution equilibrium. So let's just discuss about solution equilibrium in a different manner. So we can say if you are not the part of the solution, you are the part of precipitation or precipitate. Why we can say? Because the rate in a solution equilibrium, the rate of the forward reaction, that is the rate of dissolution of salt, is equal to the rate of backward direction, that is the rate of precipitation. So if you are not the part of the solution, you are the part of precipitate. So in this way we can say must be at the saturated point. So that means at a saturated point where the dissociation or dissolution can be occur, complete dissolution can be occur, the rate of dissolving is equal to the rate of precipitation, but amount of solid is not equal to the amount of dissolved. So let us discuss about chemical equilibrium. If in a mixture there are two reactants, reactant A and reactant B, and with a time A plus B will associate and form C plus D, which are product. So C and D will start to form. As more C and D form, reverse reaction will start up, more A and B will form. So eventually an equilibrium will be reached if all other conditions remains the same. So we can say rate of forward reaction is equal to the rate of backward reaction. So we can better understand by in this manner. If this reaction we can better understand by in this manner. If t is equal to 0, where t is the time, then no reaction will occur. When t is equal to x, then what will happen? Forward reaction will occur. Then we can say 1 mole of C and 1 mole of D will form. Then what will be the concentration of A and B? This will x minus 1 and x minus 1. Okay. So after some time, when this reaction goes to the backward direction and the rate of backward reaction will increases, and after some time the rate of backward reaction and the rate of forward reaction will be stabilized, and this point is known as equilibrium. That means A plus B, the concentration of A plus B is equal to the concentration of C plus D. Moving to the next slide. Le Chatelier principle was given by scientist Le Chatelier, and according to him, when any system at equilibrium is subjected to change in concentration, which is C, temperature, which is small t, volume, small v, or pressure, small p, then the system readjusts itself partially or counteract the effect of the applied change, and a new equilibrium is stabilized. So what will happen? When the reaction starts, this will go into the forward direction. As the amount of product will increases and the amount of reactant decreases, this will go to the reverse direction, and this will happen when the reactant and product amount is stabilized. Then we can say that this is known as equilibrium state. For example, a day at beach, if we talk about a day at beach, in the morning the water is cold, but afternoon water is hot. Why this will happen? Because in the open ocean and along the shoreline, wind mixes the water around and brings water from the bottom of the ocean, which is cold and nutrient rich, to the surface of the ocean. So we can say, by the interaction with the atmospheric air, this will cold in the morning but hot in the afternoon. So this is the example for Le Chatelier principle. I hope you all are understand about today's topic. So in this session, we have been discussed about the chemical equilibrium, its definition, example. Then we have been discussed about different kinds of equilibrium like solution equilibrium, phase change equilibrium, chemical equilibrium. I hope you all are understand, and if you have any query, any question, you can ask me through the mail or with the help of Swayam portal. Thank you so much.